So let's go ahead and get started. I got to take off these little emoticons. Sorry, I haven't purchased the software yet, so that watermark will still be there for right now. Okay, so again, if you guys aren't reading the book, you should be reading the book. It's good stuff. It's not possible for me to go into detail every example that there is, so make sure that you guys are doing that on your own time. Okay, so today we're going to be doing more review. So starting with 1.4, so this is functions part 1. Okay. So the first thing that we need to do is, what is a function? Okay, so some words that you need to know. We need to know what, so I'm just gonna group a whole bunch of words. So input, people are still coming in. So input, which is the same as the independent variable. Right, versus which is output, which is also known as the dependent variable. Okay, now when we're talking about inputs, we talk about domain versus range. Okay, so domain is what works and not works for the input. And then range is the same thing. It's what works for or not for input. Okay. Sorry, the Manicam's getting in the way. So that's really important that you need to know. So there's some vocabulary that you have to be familiar with. Another thing, note that a function must have only one output for each input. Okay, so for example, we have a circle is, oops, I'm off the screen. So a circle, is a circle a function? And the answer is no, because for areas, there is a place where for one input, there's two different outputs. So a circle is not a function, right? So obviously, things that are not functions are still important to us, but to be a function, it can only have one input to each output. Okay. So again, if you guys need to say anything, you can turn on your mics, and you can also type in the chat. It says, will you post the notes to Google Classroom? Yes, this video is being recorded, so you can go on and you can watch this video in Google Classroom. I've already posted, so this, as you can see, I'm using Manicam, so I'm streaming this, and it will be on YouTube hopefully by 3 o'clock. Okay, Bethany? All right, so next thing, how to evaluate a function. Yeah, you're welcome. I can tell people now I'm a YouTube streamer. All right, so how to evaluate a function. I just want to show a couple things here. So in function notation, let's say I have g of x equals negative x squared plus 4x plus 1. So a couple things to remember, right? This is the output, and this is the input. Okay, so what we're going to do now is to evaluate. Yes, very famous, very big famous deal. YouTube streamer extraordinaire. Me and Beyonce are friends, so you can drop that your teacher is friends with Beyonce. All right, so first we're going to try a couple of things. So first, let's say I want to try g of 2. Okay, notice what's different is my input. So notice how this input was x. What this means is that I'm replacing all of my x's with 2's. So what would this look like? G of 2 would equal, now it's super important because my other class is having issues with this. Whenever you plug in, you should plug it in with parentheses. So I'm going to have negative 2 squared, quantity 2 squared plus 4 times the quantity of 2 plus 1. Okay, so then when you go to evaluate this, you're going to get something like this, and then from on there. So I'm not going to do the answer. I hope that doesn't bother you. It's just I don't have a lot of time, and the answer is not important. What is important is when you see this, you're replacing the inputs with 2. The next thing I want to do for you is, maybe you guys haven't seen this yet, but this happens a lot in pre-calc and calculus, is that sometimes we don't want to plug in a value to evaluate. We want to plug in another function. So we want, hey, like we know that weather is a function of time, but also a weather is a function of smoke fires. So we have an equation for how the fires are spreading, and we can plug that into our weather equation to see how that will affect our weather. So really important to be able to do this. So how would we do this? Well, notice how I'm replacing my input. So everywhere I see an x, I'm going to replace it with x plus 2. So again, parentheses, super important. So I'm going to have that negative quantity of x plus 2 quantity squared, right? So see how the negative's still outside, and now it's a binomial squared, and then plus 4 times the quantity of x plus 2 plus 1. Okay, so again, I just went through my original equation. Anywhere I had an x, I'm using parentheses, and I'm replacing there. If you guys are forgetting how to square a binomial, the easiest way is a box. So x squared, 2x, 2x, and 4. So then this would be negative, right? Keep the parentheses. X squared at 2 x's, so that's 4 x's plus 4. And then I used up the squared, and then here I would distribute. So I have plus 4x plus 8 plus 1. And then the last thing I would do here is distribute the negative and combine like terms. Okay? So again, I'm going to move on unless someone says something and keep going from there. Okay? So that is your basic how to use function notation, how to plug in, how to evaluate. And then make sure you guys simplify all the way down. I didn't because I want to make sure we get through everything. And then you can stop me when you have questions. That way you are dictating what I spend time on. So make sure if you get confused or you're uncertain to ask me a question. Yeah. Oh, you're making me all jittery because you get me all excited. All right, so next I want to just make sure you guys understand how to use a piecewise. Right, not a pennywise function because that's not fun. Okay, so a piecewise function. So if we take a look at a piecewise function, so I might have a function, but it's defined by two. Ooh, my brackets. Like, crap, it's got to be better than that. Okay, I'm writing in pen, so I'm just gonna let go. But there's my bracket, and then I have maybe x squared plus 1. If x is less than 0. Your book leaves out the if, which makes me really sad, but I guess it saves time, so I'm all for being lazy, but I like to put the if because then it says you're only doing this if x is less than 0. And then we have x minus 1 if x is greater than or equal to 0. Okay, so just a couple of things that we need to be careful about. Okay, so let's say I am doing f of -1, right? So make sure you look at your input, and now we have these statements telling us which one to use. So if I have f of -1, right, that's less than 0. So I'm going to plug -1 into this one. So you have to be really careful, right? I don't want to use this one because this is only if it's greater than 0. So I'm going to take -1, and then again, using parentheses, I'm going to fill this out. Okay. So now, for example, if I had f of 0, okay, so then what we're looking for, see how this one's less than 0, this is greater than 0? You're looking for that little bar, right? Because that little bar means it equals. So I'm going to use this one because this one equals at my 0 there. So I'm going to have 0 minus 1, so I'm going to get negative 1. Okay, and then if I wanted to do f of 1, again, so 1 is greater than 0, so I'm going to use this one. So I'm going to go 1 minus 1, which is 0. All right. So hopefully you guys are doing okay so far. I know not as exciting as last lesson, but we got business to do, and when it's business time, I get my business face on. So make sure you guys know how to do a piecewise. Make sure you know how to do that. Does anybody have any questions? If I move ahead and you still have a question, just still let me know. I can always go backwards, right? It's like I always tell that to whoever's in my car. If I make a mistake driving, we can always, this car has a reverse, right? All right. Let's get going on here. So what have I done? Okay, so now we're going to talk about domain of functions. Okay, shoot. When is class out? I never know when class is out. Can someone type in chat when class is out? Or not. Thank you, 12:10. Thanks, guys. I have to keep looking at the time. Okay, so let's talk about domain. Thanks, guys. You rock. I appreciate you guys. Okay, so domain, we have to remember, is what works for the input. Okay, now some notes. Often it is more easy. I feel like my grammar today is terrible. Like, who speaks like this? Okay, often it is more easy to find what does not work. Now, this next part confused my other class quite a bit. So if you're sleeping, make sure you guys are paying attention. There's lots of different ways to write domain. Okay, so let's go over. Of course, I didn't save my notes from last time. Maybe I did. This would save me a lot of time. Algebra notes. Algebra notes. Algebra notes. Algebra notes. Algebra notes. No one likes algebra. Okay, well, I'll just make stuff up. Okay, so there's lots of different ways to do domain. So I'm just going to try to think of all of them really quickly. So one is inequalities. Okay, I like algebra too. I was just joking. Inequalities. So so for example, I might say the domain is such that x is greater than or equal to 1. So you guys have seen that before, right? And maybe the range is y is less than or equal to 15. Okay, so I just made all of that up. I'm just showing you how to state domain and range with inequalities. There is set notation. Set notation is like the most formal of all the notations. So this would be like domain such that x, oh my gosh, I haven't used set notation in so long, is an element of all reals. I think it's like that. Or you can say range is a set such that y is less than or equal to 15. Okay, and then there is and then what we're going to be using is interval notation. Now, you might be like, Kreft, why do you hate inequalities and set notation? It's not that. It's just interval notation is the fastest. And when you get to AP Calc, you're going to want to go the fastest because AP Calc is timed. So I'm going to go ahead. I just realized I'm not on the screen. Okay, so let's go ahead and talk about this really quick. Talk about it. So interval notation, how would I write this? Sorry, I should have done. X is greater than 1. So I would say, so if it's greater or equal to 1, so I would say the domain is equal to 1, and then it goes off to infinity. And then the range is less than, but equal to 15. So we need to talk about this a little bit more. I'm pretty sure you guys have learned interval notation, but I do want to go over a couple of things about interval notation. So just remember that these symbols are these symbols now, right? And that means it cannot equal a number. And then these symbols are now brackets, and they equal. Okay. Now an important note, notice how I said cannot equal infinity. So infinity is a concept, not a number. So it can never equal infinity because infinity isn't a number. So that's an impossibility. It's just an idea. So the idea is that I go from 1 and then I go to positive infinity forever. So you can never say it includes infinity. So on your homework, you're going to be using interval notation. So just a real quick little quick thing here. Let's do one more example and then I got to get going. So let's say f of x equals the square root of x. So I'm going to sketch a graph of this really quickly. It's the claw. Okay, looks something like that. So if I wanted to write domain for this, right? So notice how there's only one special point, and that's at 0, and then it can be everything above it. So I would say the lowest I can go is 0, and it can include 0. And then I would say it goes to positive infinity, and then there's my domain. And then for my range, I would say, well, it looks like it never is negative, right? My output's never negative, which makes sense because I'm not taking negative numbers. So I would say that it goes from 0 and then infinity, like that. Okay? So that's how you use interval notation. You always start with the smallest, and then you go to the biggest. Okay. Another example, if I have a function that looks like this. Okay, so it's like a piecewise function, right? Then for my domain, right, if I wanted to know the domains for the positive, I would only go from here to here, right? And if I wanted my domains for the negative, I would go here to negative infinity, right? So if this was A and B, so for positives, I would write A to B, and then for negatives, actually, oh, I just did that. Some calc books do include zeros for your positives. Don't worry about that. That's not going to show up in pre-calc. That's a calc topic. I should have done this because doing the other one's just going to confuse people. So just do open brackets there. Anyways, it's just an example. Negatives would be right. It would be B to okay. All right. So obviously we need to practice that because that Mr. Kraft made a mistake, and when Kraft makes a mistake, everyone turns into wild, crazy people, and we all want to just run around and be crazy. Okay. Okay. So I want to do a couple examples. How am I doing for time? Oh my God. Yeah, I gotta get going. All right, so I can only do a couple examples. So here's example 1. 1 over x plus 5. Okay. So you need to know parent functions. That's what we're talking about next class. You need to know parent functions. You need to know parent functions. You need to know parent functions. Okay. So here, in a rational function, you can't divide by 0. So what we need to do then is what causes the bottom to be 0, right? So sometimes it's easier to find where it breaks rather than what works. So what I'm going to do is what I'm going to say is the bottom cannot equal 0. Okay, do you see, right? Because I can't divide by 0. So I'm saying the bottom cannot equal 0. So I go ahead and solve this. So boom. The domain for this is, now if I'm going to write this in interval notation, I would write it like this. I would say negative infinity to negative 5 and negative 5 to infinity. Okay. So here's example 2. Let's say I have the square root of 4 minus 3x equals h of x. Okay, so now a square root, I just drew one of those earlier, right? We know that the domain for a square root has to be 0 or greater. We can't take the square root of negative numbers, okay? So what we're saying here is I can't take the square root of negative numbers, so think about that. And Bethany, you should be on top of this because you love algebra. So how do I convert the statement, this can't be negative, into a statement? Well, it's an inequality. So 4 minus 3x has to be greater than or equal to 0. Okay, so I'm going to go ahead and solve this. Now, the reason why I picked this one, because you guys remember what happens with inequalities if you multiply or divide by a negative? Right? If you multiply or divide by a negative, this sign changes. So it's going to be x is less than or equal to 4/3. Okay, so how do I write my domain for that? My domain will be, so it's less, so 4/3 is going to be the greatest, right? So it has to be less than, so this is the greatest. So negative infinity, and it can equal 4/3. Okay, so I hope you guys are doing okay with that. That is domain. We're out at 12:10, which means I'm moving forward. So that was 1.4 in a nutshell, in a really quick nutshell. So does anybody have any question about finding domain? So finding domain. Anybody have question about interval notation? Going back here, I just realized something. So where it says they cannot equal, so on a graph, that's an open circle. And on a graph, this is a closed circle. Right, so when we see a graph, right, all the points are closed because it can equal that on the graph. So a line, kind of like this, is made up of infinitely small fill-in things. Why did you flip the sign? Oh, so so that's a property of inequalities. To do that, to show you why that property works, I could do a quick little mini lesson on inequalities. But if you want, join me in my office hours and I can do that, okay? And if you want, I was just thinking, like, how can I teach this really quickly without doing a visual? Just think of it like this. Do you see how it says negative 36 is greater? Well, think of it, we want to get to x, right? Think of negative as opposite. So when we move the opposite over to the other side, we're no longer saying the opposite of 3x is greater. We're now saying x. So there's a way I can explain it without showing you the visual, right? So we're saying the opposite of 3x is greater than this. So when I divide it, I'm no longer talking about the opposite. So I have to flip this because it's opposite. So think this is pointing to the right. What's the opposite of pointing to the right? Pointing to the left. So you're taking the opposite of this, but you're taking the opposite away. So you got to change the sign because what you're doing is taking the opposite. So Elizabeth, I hope that helps. If it doesn't, come see me in my office hours, okay? I thought that was a pretty cool explanation, though. I just thought of that. All right, so 1.5. So functions, part 2. Okay. Okay, I'm looking at my notes. All right. So let's talk about math, baby. Let's talk about math. Let's talk about functions. Yeah. Okay. Let's talk about range. Okay. So range is where does the output exist? Okay. So this is really easy to do if you have a graph, if you are looking at it. It's harder to do if you don't have a graph. And as you can imagine, when we get to calculus, we're not going to have a graph. And so we have to find ways to figure out, okay, where is the output going to be? Because we're going to be looking for things in the output, okay? Now, I just want to show you a picture. I wonder if this is going to work. Enhance. Okay, so please note that, right, domain is my input. So if my x-axis is going left to right, that my range is up and down. So if you can see this, my range here, just on this interval, on this domain interval, I go from -3 to +3, right? So -3 being my lowest point, +3 being my highest point. We're going to talk more about that next class because you guys probably heard that about as a min and a max. And so we'll review that next time. Okay. What else do we want to talk about? Vertical line test. So you have to be really careful about this. Ooh, I'm too zoomed in, aren't I? Thank you, Wendy. Okay, so the vertical line test. You have to be really careful. There's 2 tests. So this is just one of 2 tests. So this test is to see if you have a function. Okay, so example of this, if I make a vertical line anywhere on this graph, the line should only touch the function once to be a function. Okay, so the line should only touch the function once to be a function. So as you can see in this one, it touches it only once. And if I were to go back and forth like a scanner, it should only have one output. Another example, we've already talked about this a little bit, is a circle, right? So if I try the vertical line test, it might work at 2 points, but if I look here, boom, boom, 2 points, not a function. Okay? 2 points, not a function. Are we doing okay with that, guys? Vertical line test? Okay. Thank you, I appreciate that. Thank you, Lauren. Okay, so let's take a look at what we got next. Finding zeros. And again, guys, I'm going awfully quick, and I'm not spending a lot of time on things because this is review. So again, when we do review subjects, I hope you guys just chime in and tell me if you need more. So finding zeros. Okay. I'm on the wrong page, of course. Okay. So remember, okay, so finding zeros. Zeros is just a fancy word for Hey, is that my mic or is someone's? Okay, so finding zeros, we have x-intercepts. Brandon, I just muted you, and if you were trying to say something, I'm really sorry, but you can shoot me a text if you were trying to say something, not a text, but a chat if you were trying to say something. Finding zeros are just x-intercepts. Okay, so finding zeros, that's defined by when f of x equals 0. Okay, so you guys need to be able to do this. This is huge. They're really important. So, for example, I'm not doing great for time. Okay, so I don't have time to do all of these. I'm going to let you vote in the chat. You're going to type in F, G, or H, and that's the one I will do. So you're going to type in F, G, or H, and that's the one that I will do. So it's a tie right now. G is winning. G is winning. All right, I'm doing G. Okay, so here we go. So I would take 0 equals the square root of 10 minus x squared. So the first thing I want to do is I want to get rid of the square root. So remember, this square root, isn't that just 1/2, right? You don't have to do this stuff, I'm just showing. So if I want to get this to 1, what would you have to multiply 1/2 by to get to 1? And that's squared. So what I'm going to do is raise this to the second power, right? Because 2 times 1/2 is just 1. So those go to 1. 0 squared is just 0. Okay. So then moving forward here, I'm going to subtract 10. So I get negative 10 equals negative x squared. I don't want the negative here, so I'm just going to go by and divide by -1. Doesn't matter if you divide or multiply, they're the same thing when you're doing that. Okay, and then I want to get rid of the squared. Now, this is where we have to be careful. Here, the square root, right? The square root is always positive, right? Always positive. So we don't have to worry about a negative answer when we square it. Does that make sense? So this is always positive. So when we square it, right, the domain and the range are always positive. So when we square it, we're always going to get a positive. But here, if I look at a square root, a squared, see how there's negatives? There's a negative input. So when I'm taking a look at this, if I square root this, a square root can only have positives. So I'm going to lose that negative answer. So when I go here to square root this, I'm going to have to add a plus or minus. So I actually end up with 2 roots, okay? 2 zeros, 2 x-intercepts. So that's really important there. And we're out at 12:10, right? And I have 15 minutes. All right. If I have time, I'll come back and I'll do H, because some people ask for H. Are we doing okay here, guys? Okay, thank you. I got one response there. I appreciate that. All right, so let's take a look at this. What's next? Increasing, decreasing. And remember, you guys haven't asked a lot of questions, so make sure if something comes up, I know this is review, but make sure you guys are asking questions, right? Because your homework will depend on it. So increasing, decreasing. So it's important, and I think people always get confused here. The way we read left to right. Okay, and if you remember that, that's how you read a graph. You read it from left to right. So sometimes what happens is that they'll take a look at this picture and they'll start at 0 and be like, oh, look, we're increasing to the right. And then they'll go this way and they'll be like, oh, look, I'm increasing to the left. And it's just like, oh, what just happened? When I do this, I'm going left to right, right? I'm reading from the left to the right. But as soon as I did this, I'm starting on the right and I'm reading to the left. So super important. We read left to right. So I would start from here and I would say I'm decreasing. And then here I'm increasing. Okay? So one of the things you're going to have to do is you're going to have to state the intervals that something is increasing or decreasing, right? So remember, increasing is just output is going up as we move right, and decreasing. And hopefully you guys have all read the book, right? This is not by any means the mathematical definition of increasing, right? This is like Chris, we meet each other in the street and we're talking about what increasing is, right? So output is going down right? So when you see me in the street and you'd be like, Crypt, it's going down, and I'll be like, no, man, you're walking to the left, you're actually increasing. Then you'll get my joke. All right, increasing, decreasing. We should do an example together. All right, zoom, enhance. Okay, so if I were to take a look at this first problem, if I was really cool, I would be able to draw on this. But so I would want to be able to state the intervals in which this is increasing and decreasing, and I'll get that functionality in a little bit. But I would say it looks like here I'm going from -2 to 1. I'm increasing because from left to right I'm going up. At this point, we call this a critical point, but you're not going to learn about that until calculus. So a critical point is when you are not increasing or decreasing, but we'll learn about that later, right? This is going to be a maxima. And then from -1 to 1, we're going to be decreasing. So just to make sure what I mean by that, I would say this, -2 to -1, we're increasing. And then I would say from -1 to 1, we're decreasing. Okay, of course, I'm totally zoomed in and you can't see anything, so that was lame. Okay, do you guys see how I wrote that? Right, so I'm not including the values themselves, but I'm just saying that's the interval at which it is increasing or decreasing. So again, from -2 to -1, I'm increasing. From -1 to 1, I'm decreasing. And then I would say from 1 to 2 or infinity, depending on how they define this, I would say this. Okay. Your book doesn't put arrows on it. It's the only thing I hate about this book. So just be really careful. So on this one, yeah. So your book doesn't put arrows on it, which is actually an error. If they wanted you to say infinity, they should put arrows on it, and they don't. So mathematically, that's the only thing I've found so far where this book is wrong. So in your book, if they don't give you a domain restriction and they don't put arrows on it, then you're going to assume it goes on forever. Okay? So again, if they don't tell you a domain restriction, assume it goes forever, because that just totally messed me up, because this would have to be negative infinity. Okay. Oh shoot, I am talking about max and mins today. Ha! Okay. How are we doing for time? We got 10 minutes. Okay, so again, increasing, decreasing, you're going to have to state the intervals. No one said anything, so I'm just going to imagine in my head that everyone is not in class, but you're outside and you're doing a slip and slide, because that sounds way more fun right now. So let's do max min. I don't condone that, by the way. You should be here. So let's talk about minimum and maximums. Okay, so I can't teach this without doing a little bit of calculus. So these happen at points with no increasing or decreasing. or the endpoints. Okay. Now, this definition right here is way more than you need for this class. Okay. But I need to do that for you because a lot of you are going to be going on and take calculus, and you need to know this. So max and mins happen when you're not increasing or decreasing for the endpoints. So if I zoom in here, so for example, right, so we have relative minima, we have relative max, and the endpoints, so I hate this book, you should be able to endpoints. The endpoints can also be relative. So right here you have a max, but right here, isn't that relatively lower than this point, right? So the endpoints can also be maximums. So again, this one is a max, obviously, but relative, right? If you ignore everything else in this problem, if you ignore everything else, this point right here is also a min. If you guys want to know, you can think of this as like, here is Mount Vernon, right? And here's Burlington, right? But like, here is concrete. Now, concrete's really low, right? But if you look way over here, I mean, it is better than alger. So that's just an example of how max and mins work. Sorry if anybody here is from alger or concrete. It's just a joke. All right. So max and mins. So the book tells you to just do a zoom or trace. We're not going to do that. We're just going to look. So I think the book does, so a relative max or min just means based on things around you. For example, Burlington is not that great, but when you compare it to Cedro, Burlington's pretty good. So that would be a relative max, right? So just think Burlington, not so great, but still better than Cedro. So Burlington would be a relative max. Now an absolute max min, that means it's the highest possible, highest or lowest possible. So an example of that would be Mount Vernon would be an absolute max, right? Because in the valley, you're not getting better, right? Maybe Anacortes is close, but absolute max is going to be the highest there, okay? Big Lake, or some of you guys are from, now I can't think of town names, La Conner, okay? Absolute max, relative max, min, okay? So all you're going to have to do is be able to look at a graph and be able to assert those. You're not going to be doing this algebraically. This is calculus, so you're going to learn how to do this in calculus. So just be able to look at a graph and say, hey, is it a relative, a max? So for example, I disagree with how this picture is labeled. So this would be an absolute max. And down here, if this ended, so if this was an endpoint and this was an endpoint, this would be an absolute minimum. And then these two would be relative. All right. All right. Now, I do have some time left. So I want to go back and I want to do some more problems with you guys. Because I want, yes, good, I have plenty of time. Okay, so I just got through everything quickly so that I can spend more time with you guys working on stuff that you need to do. And since you guys didn't slow me down, I'm gonna want to, oh, by the way, in the book, if you guys want a preview of calculus, example 11 is what we do in calculus. It's pretty fun. All right, so let's go back and I'm gonna have you guys try the domain and range ones. What was the questions that I had you vote on? Oh, there we go. Finding zeros. Okay, so it's finding zeros. Here, I'm actually going to pick a different one. I want you to find the domain and range let's try this one. So, oops. And then I'm going to, I have these little cool features. Oops. I'm going to do really quickly. You guys are going to get 30 seconds. Okay, maybe 30 seconds wasn't enough time. There you go. Let's try again. Okay, so we're out at 12:10, so this will be our last. All right, so let's go ahead and take a look at this. So what I would do here, so I notice a family function. I might sketch that family, the parent of that family function, just really quickly to be like, okay, looks like range is all going to be positive, and it looks like domain has to be positive as well. So the range, it looks like, is going to be okay because we don't have anything out here affecting it, right? There's no translations on the outside. There's just a translation on the inside. So for the domain, I know that this has to be greater than or equal to 0. Okay? So if I'm going to do that, I'll go ahead and add. Okay, so I know that x has to be greater than 16. So if x has to be greater, this is going to be my smallest. So I'm going to say 16, it can equal it, and then it can go on theoretically forever. Okay, and then domain, what's the lowest our domain can be? It doesn't look like anything's going to be negative, so I want only positives. So I'm going to say, can it be 0? Yeah, square root of 0 is going to be 0, right? So, and then remember, guys, this is just square root of x, right? This is just a sketch, it's not this. So then I know that it's going to be, it can equal 0, and then it's going to go. Okay. All right, so it's 12:08, so a couple things I need to remind people. Make sure you guys are getting your assignments done. I need to update Skyward. I haven't done that yet. I'll do that later today. Make sure you're getting your assignments done. Remember, if you need an extension, you can ask for an extension in WebAssign and then shoot me an email because WebAssign doesn't. But you need to do, if you do both, that helps me out incredibly, very much. And then I've only had, I think, 2 or 3 students come to my office hours for help. So make sure you guys are coming to my office hours to ask questions. So in the final minute, does anybody have any questions?